Okay, thank you everyone. We start to uh, do a walkthrough about the what is the experience across the virtual and cloud native experience for developers. This means a DevSecOps experience. Originally, this talk start a big demo lab, but now we're squishing in this talk, and uh, I hope that you enjoy this recommendation that we start to talking about what need to do focus, and if something you want to start to migrate your work or migrate your strategy to develop for cloud native environments for this new era of environments, be focused in some recommendations that we are doing in this presentation. Okay, we do the walkthrough about the introduction, what means this strategy, what means the legacy stuff, new stuff, cloud, virtual, Kubernetes, etc. And we repass a little bit about the Cloud Native Foundation, some of the open source software, yeah, different opportunities, risk that you need to put focus when you start to develop in the Cloud Native world. Then we start with a little bit of introduction about that.
Um, Hi guys, I will present some definitions. Like, for example, currently the developers lives in two worlds. Let's call legacy, that is basically use VMs, and the other one that is cloud. We use containers. For developers, it's really hard to work in these worlds and maintain their applications in that at that level or confidence. Um, to commit that compliance and to commit everything, they have to mm, follow different rules in different environments. It's not the same use the code in a VM that have it in a container currently. Um, why we need to unify? Okay, the before, let's call legacy or in VMs, you have a full system operating with all the libraries and everything in place. Basically, every application uses a lot of memory, RAM, and they used to have, or how can I say, steal or took memory at gigabits. Currently, with containers, they use less memory, and they have to be short and measured in megabytes. That is a completely different thing and different form of troubleshooting. Um, for, also, the change of deployment is completely different between the pipelines in using VMs and uh, and containers. Sorry. Um, sorry. Why we need to unify these words? Basically, once the developers take away the part of the system, they will be able to develop applications faster, and they will forget to do maintenance or plumbing in a systems that is not related with the application. They will become more as they will be focused and develop instead of be how can I say um, um, we have a word in Spanish, but it's not good. Todólogo is it's completely new way. You know? They will focus in the code, not in plumbing or fits the environment to deploy applications.
Uh, the necessity, the challenge of hybrid reality, and now even as we see the value of unification, the challenge of hybrid reality becomes clear. Developers have are being asked to operate in two words at the same time. On one side, we have the virtual machines, still essential for running legacy applications, meeting compliance requirements, and serving industries where regulation demands stability above all else. On the other side, we have the cloud native containers world, powering microservices, function as a service, and even decentralized apps. This hybrid reality is the tension we must resolve if we want developers to move faster, stay security, and keep innovation, following without the begin weight down the complexity. Fragmented workflows and cognitive load onboarding curves. And this challenge of hybrid reality quickly translate into fragmented workflows because VMs and containers involved in parallel. Developers often end up with the complexity different tools and pipelines to manage it work. Think about we duplicate and for across CI/CD system monitoring stacks and lifecycle management. What should be the streamlined process become two or more disconnect ones? The impact fell directly in developer experience instead of a smooth path to delivery. Teams face inconsistent workflows that show everything down. Every switch from one tool chain to another means context switching, and the context switching means lost productivity and higher cognitive load. And the fragmentation doesn't just slow down. It also creates security blind spots. Traditional perimeter security models were built for centralization environments, but they simply don't fit the reality of decentralization applications. Security designed for virtual machines doesn't automatically translate to container runtimes, where workloads are ephemeral, dynamics, and orchestrated at massive scale. On the top that, the software supply chain is growing more complex across the multi-platform environments, increasing the risk of the image or unverified dependencies into the production. Without end-to-end the visibility across the both VMs and containers.
Okay. Now we start to talking about the cloud native foundation and container. The cloud native foundation put the best practice for how to build these kind of applications. That is important in this new era because all of things are really close for get, really close for catch. Web portals AI now is in the play, and we need to be focused in maintaining standards, follow the best practice because now you can catch all of different elements in the different web portals, but need to be focused in three important things: maintain the standards, transparency, and security. Security now is the more complicated stuff in any company if you want to go to production. Is the pain for all of developers right now because all of computers or all of applications are geographically distributed, and it's really complex to communicate all of these applications and offer security, validate the data, ensure that your data, secure data or sensitive data are in the correct state. No? Then we need to maintain focus in how to offer the security using the best practices. Using we don't need to reinvent the wheel. We don't only need to maintain focus in the best practice. There are different ISOs that you need to align with them. If you want to focus the 12 factors of how to build applications for cloud native environments. That means that you need to we need to use repository code for life cycle. You need to use a dependency strategy, security dependency download, security dependency images, image revision for maintain all of these standards together for build secure applications, and be sure that you are offering security across all of your supply chain. Because now we have a lot of risk. The communication between one data center, other data center, one country, other country is really complex. You need to be sure that all of sensitive data, almost in 90% of the government regulations across the world, request that you maintain the data in the country that you are requested it. You need to maintain all of sensitive data encrypted in the transaction. You need to maintain all of these different data in security databases. You need to align with them. You need to validate that your code maintain this and you don't put any of these sensitive data into the logs, for example. Other important thing is you be sure that you are using the No 42001 standard for AI that talks about the ethics. If you are using AI for create your application, if you are using AI for deploy your application over the cloud, you need to be sure that all of consequences or the use AI in your code is your responsibility. No, you need to keep this security in your development, because now the security almost is responsibility of the developer. Now we start to talking a little bit about the ethical stuff. You need to be sure that you not only start to doing codes, algorithms, validate that the use case is working well in the main focus of your application. No, the governance of your application is part of some developer activities. You need to start to doing how to involve the security in my applications, how to validate and offer the transparency to the user that all of their application is using correctly. And you need to maintain the ethics, accountability, and trust about all of your supply chain. No, we start to talking about a little bit about how to join all of this together into containers and cloud native foundation work.
Sorry. Again, I'm here with these new containers. Basically, they are breaking that. They are making the bridge to become a decentralized infrastructure. As I said before, having the application in one server keep you stay in one site, and it was higher in cost, and the maintenance also is a lot of higher. Now, with the decentralized applications, as you can have your application in any part of the world as soon as you have a connection internet or VPN or basically internet. You can deploy your application and have access. That is why the developers get unified experience to. Sorry, I lost my idea. That is why containers are the future for distributed applications. Now, so why use decentralized infrastructure? They allow portability, scalability, security, and composability. Okay, portability, you can run it in any part as soon as you have the runtime appropriate, and runtime basically is a standard for everyone. Currently, we use container ID as mostly in the cloud, and scalability. You can have your application according on the demand. Basically, if you need more accessibility to your application, you easily call your pipeline and deploy a new pod or increase the resilience of your application. Security. Once you go to the cloud, basically the security becomes really, really important because you don't have the full control on that part as we used to have it. You know, have a cryptography standard is important in any decentralized application. Then we need cryptography identity and signed artifacts to do this. And basically, the composability, and when we apply this, the application becomes modular. We can add or remove things easily, and basically in one pod we can have n number of containers. Talking about the future. Containers are now very core how the cloud foundation, ecosystem, and decentralized cloud operators. The same platforms like OpenShift, Kubernetes, and Constellate are unified, decentralized, and centralized works. You can have it in your on-prem or in the cloud. It will be the company decision or the decision of your architecture in the application. And looking forward, we need cryptography truth authentic mechanisms. Okay, without those mechanisms, we cannot basically use the cloud. We will still have to be on-premise. Security models and how they are changing. Okay, before, I will not say before. Currently, in the real work scenarios, we are still using VPNs for mostly of the things. Like we cannot change politics or compliance about this, but the world is still moving to the cloud. Before we used to have a VPN, a completely connection to our system. Now, when we put it in the cloud, we need a different path or different way to do this. That is where different applications or different methodologies came into the scenario. There are basically the one standard that is called SPFFE, and the execution of this standard, SPIRE. They came in. Basically, that is the new way to verify who is who doing what. Okay, we cannot have anymore like a database access with a password and open our application. We need to log in with SAML, or different ways to connect to our application. Okay. We need to use a sign store and cosigns. Basically, use tools like Heber, OPA. They are an OPA gatekeeper. They they can build our policies into our clusters. This is a new scenario for developers. They must think to implement a way to be trackable in their applications. Before, the developers, they didn't have to be worried about these policies. They only deploy the application, you got the connection by VPN, and start working. Now, with the cloud, we need to change that part. We need to use that policies. Okay, with this, something came into the scenario. Sorry, I'm blind. Zero Trust networking, secure orchestration, and immutable infrastructure. Once the developers take away the infrastructure, we don't care, basically. As developer, I will have my cluster or my connection cluster to do my pipeline and go for it. With zero trust networking, this is basically when you open your application to the world. That is when you need be very cautious. Currently, there is how can I say? There are two methods. There are one method of authentication that is your password plus your text message token in the phone or message that you open, and you need to, okay, I set my password and plus add this code. No, that is what it came into this scenario. The same for developers. They have to be very cautious. They cannot just release the application as they used to. They have to be more secure.
Right now, unifying developer experience across the virtual and cloud native world. Unifying developer experience across the virtual native world. So after addressing security, we return to the bigger vision, unifying developer experience today. Developer still live in two parallel works. On one side, VMs, critical for legacy systems, compliance heavy industries, and regulate workloads. On the other side, containers, the engine of cloud native microservices, and decentralized apps. The challenge is that these words really connect seamlessly. That's why the global must be one workflows, one experience across both environments. When we unify developer experience, we eliminate friction, reduce context switching, and accelerate delivery. But unification isn't only about the speed. It's also embeds a stronger security and governance directly to the workflows. In a short, a unified developer experience is how we bridge past and future, liberating legacy systems with embracing a cloud-native innovation. Cross-plane platform abstraction infra provisioning. To make this unified developer experience, we need tools that abstract away infrastructure complexity. This is where cross-plane plays the key role. With cross-plane, infrastructure is provisioned Kubernetes objects using the same declarative model developers already know. That means no separate language, no isolate provision scripts. Use Kubernetes native definitions. By doing so, cross-plane abstracts away multi-cloud cloud complexity. The biggest benefit, developers can finally focus on application, not plugin. They get consistent workflows, while operation gain governance and control, delivering unification, the infrastructure layer. One infrastructure is abstract with the tools like crossplane. The next challenge is unifying workloads themselves. This is where virtualization with Kubernetes platform or Tanzu, VMware Tanzu, comes in. By running VMs and containers side by side on the single platform, we no longer need to maintain separate silos for legacy and cloud native applications. That means we can modernize legacy workloads without forcing a replatforming effort, giving business the flexibility to involve their on one piece.
Yeah, doing some updates of this or refreshing this kind of things. Talking about more at focus in the architecture. No, we talk about here about the decentralization. We talk about the virtualization containers. But what is better? No, what is better if you want to implement your applications? You want to deploy your applications. One of the best recommendation of 90% of the architect is be simple. Be simple and follow the standards. No, we know that there are a lot of architectures that have a really big complexity. Yeah, but you can use the standard like a Lego stack and use these elements for be simple. Be simple. You want to use open source. This is my recommendation for by start, and you can aggregate a lot of different elements like any virtualization tool, any containerization tool. Now Kubernetes is more standard. I recommend Kubernetes. All of products based in Kubernetes are well, but you need to start to using all of these elements for be simple and for maintain the standard, maintain the security, and maintain all of the things together. One of the different elements that we are using now for deploy is Kubernetes, but not only Kubernetes pure, because now we have two different big complexity verticals in the dev side, that is function as a services, no? And microservices. No other companies say, we are building or we are deploying microservices. Could we know? A lot of different companies, the most biggest companies are using legacy. No? But they are integrating in the new world with microservices and a little bit with function as a services. But we need to integrate these two worlds together. We need to integrate virtualization stuff, all of different mainframe stuff with containerization, and we need to know what is the standard for communicate these together, like SSL, MLL, how to my peer mention, and maintain the standard in how to deploy these modules, how to deploy these applications. And talking about that, how to start the migration. A lot of different companies, when they start the migration for legacy to cloud native or for virtualization stuff, new virtualization stuff, have a really big files because they want to change the paradigm immediately for deploy the applications in the cloud, want to introduce the 12 factors in the legacy applications that are really monolith, and try to split all the functionality in the one step. No, we need to validate the maturity of for these kind of migrations. Try to use all of these different elements in like a cycle. We start, analyze, validate. Okay, we don't need to use in this step security. If we split this communication between database, between application, we need to start using cryptography, because remember, you need to be trust with the users that their information is secure. And it's not only that you start to put two-factor authentications, create tokens, and if between the communication of the microservices, the communication is plain. Because now, how mentioned in 5-6 slides ago, all of different microservices are split around the world. It's for the reason that we need to start to thinking not only security, not only in how to deploy new applications, if not how to integrate all of these applications with the legacy stuff. How to validate that legacy stuff is currently secure, because now all of different monoliths, all of different elements are working with TLS 1.0. And this is a really big recommendation for all of different tools that we recommend that you can use in a simple architecture for all of your application, integration with virtual machines and containers. We in the big laboratory that what we offer in other moments, we're using OpenShift, ACM, ACS, and OpenShift virtualization now, and in the past Red Hat virtualization stuff, for create these two environments and develop applications for the two worlds and integrate together. And show how to ensure the communication between them, how to deploy applications in one region and communicate with other region. But the main set is all of these applications can work together with this main stack. You can see here that you need to include security. That is main focus, security in all of different layers that you are building your applications. You maintain virtual machines because it's really complicated. At this moment, migrate all of the stuff together. Start to work with containers for all of applications that have opportunity to become a cloud native foundation or cloud native applications. Maintain the security responsibility for the developers and DevOps architects or DevOps engineers. Protect the layer, all of different layers in your infrastructure, in your pipelines, and in your applications, and maintain patch your infrastructure, and be trust and be responsible if you are using AI. Okay. Yep. And only for finishing, the ethical dimension across all of different platforms. One of the main recommendations that we offer in the different talks is try to learn about all of different technologies that are around your work. If you are a developer, you try to not only focus in algorithms, not only focus in math, not only focus in your framework. You try to learn about the next step, that is GitOps, and the back element that could be containers or virtual machines that your application is running on. Okay, it is the same. Yeah. Then we have all of different recommendations for a new age developer. We need we recommend that if you want to be a good developer in the new era, start to practicing GitOps and DevOps. GitOps is the new strategy for deploy full infrastructure, full workspace for your application. Start to thinking in security. Prioritize all of different standards. Standard is the big recommendations, and balance innovation and stability. And we mentioned here what are the 10 technologies that we recommend to use for all of your new era deployments. Okay. And thank you so much. We are the team DevSecOps in this talk for the new era for of developers. Thank you. I don't know if you have any question. No? Okay, thank you. Thank you so much.